This is lesson 914, and this is the second video for problem 934, and we're going to do question A. I want to show you how to solve this quadratic equation using all three of the methods you've been learning. So we're going to look at solving this using the zero product property, completing the square, and using the quadratic formula. Okay, so the first method I'm going to use is the zero product property. And so with the zero product property, you need to factor this quadratic equation and then set each of the factors equal to 0 and solve for x, okay? And when I say factor, I'm talking about making a generic rectangle and a diamond. Okay, so here we go. I'm going to set these up. My x squared terms go in the bottom left-hand corner. My 1's in the top right. Multiply those together to get the top of my diamond. And then remember my x terms go in the bottom. And now I'm looking for those factors that multiply to give me 27x squared and add up to give me 12x. So those numbers are 9x and 3x. Put those into my generic rectangle. All right, and now I'm going to look for the dimensions of my generic rectangle. So this has to be x and x. That would make this a positive 9, and then this a positive 3. So now I have x plus 9 times x plus 3 equal to 0. Okay, so I've taken the quadratic equation from standard form into the factored form. And we did that by using the generic rectangle and diamond and factoring it. Now we use the zero product property and set each factor equal to 0 and solve for x. So one of my roots is at x equals negative 9. The other one is at x equals negative 3. And you could also write these as coordinate points. Okay, so that was using the zero product property. I'm going to do the same equation. Go ahead and rewrite it. X squared plus 12x plus 27 equal to 0. And now this time I'm going to complete the square. Okay, so when you hear completing the square, okay, you're actually trying to make a square with your algebra tiles. So you have your equation mat. Okay, and I've got an x squared tile. The bottom left-hand corner, I have 12 x's, so I'm going to put 6 of them here and 6 of them here. Okay, so now the dimensions of this square, when we complete it, have to be x plus 6 times x plus 6. All right, and now in this corner here, I have a total of 27 ones. Okay, but when I take 6 times 6, I get 36. So I know I need to have 36 ones in that corner. So to get there to be 36, I'm going to have to add 9 to 27. And if I do it on the left side there, I need to do it on the right. Okay, so now on the left, our perfect square is x plus 6 squared equal to 9. Okay, so now we're solving for x. So we're going to take the square root of both sides. Remember to put a plus or minus in front of that square root because you're going to have two answers. So the square root is going to undo the square. So on the left we have x plus 6, and on the right we have plus or minus. Now the square root of 9 is 3, so I have plus or minus 3. And I want to keep solving for x, so I'm going to take away 6 from both sides. So now I have two equations here. So I have x equals negative 6 plus 3, and I have x equals negative 6 minus 3. And if I keep solving those, I get x equals negative 3 and x equals negative 9. And again, I can write those as coordinate points. These are my roots. Now, if you notice, those are the exact same answers we got when we did it by using the zero product property. Okay, so no matter the method, we should get the same answer. All right, so let's do it one more time with the quadratic formula. Okay, rewrite my equation. Okay, and so the quadratic formula, if you remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and when we do this, it's helpful to write what a, b, and c are equal to. So remember, a is the coefficient in front of your x squared term. So that's a 1, right? There's an imaginary 1 in front of that x squared. We have 12 in front of our x term, and we have 27 ones. All right, now we're going to just substitute these into the formula. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so we're going to keep solving. The opposite of 12 is negative 12 plus or minus the square root of 12 squared is 144. And then we have negative 4 times 1 times 27 gives us negative 108 or minus 108 all over 2. I'm going to keep simplifying here. Negative 12 plus or minus the square root of 144 minus 108 gives us 36 all over 2. Keep going, get x equals negative 12 plus or minus the square root of 36 is 6 all over 2. And then now we can split it up. So we have one of our roots is negative 12 plus 6 over 2. The other one is x equals negative 12 minus 6 over 2. And if I simplify, negative 12 plus 6 gives me negative 6, and that's divided by 2, which gives me x equals negative 3. And my other root, negative 12 minus 6 is negative 18, divided by 2, and we get that our other root is x equals negative 9. And you'll notice that those are the same roots that we solved when we were factoring and completing the square. So now you can see all three of the ways to solve quadratic equations. So now when you're trying to solve these, you want to look and see what does the quadratic equation look like and decide which is going to be the best, easiest method for you to use for that problem.